So today I'm gonna do this work on this tool, and I think I decided that I'm gonna do the Ruby part first, and I'm gonna try to complete, not gonna try, I'm going to complete the whole project and at least the part that, not the whole entire project, because then after I finish the stuff that I wanna do here, I wanna do more stuff with the templates that I get from the network acts. So I'm gonna have to study that anyway. And I was thinking about stopping that on the previous project where I did the script visualizing stuff, because I thought that it was just a waste of time and too hard, but now I realize that I'm probably will have to figure that out anyway. And I'm gonna learn a lot doing that. So after I'm done with this, I'm probably gonna, because I wanna merge those two projects together into one website. So I'm gonna have to change the layout of the page once I'm done. Let me just see. Yeah. Okay. So yeah, that's my intention. So here I've managed to understand what documents I got from that Tor stuff that I did yesterday, and it's pretty simple. There was a file called docs here. I think it was this one. I'm not sure. No, I think it was in Publix. Yeah, there was a file called docs here, which is essentially this file now that I moved outside of there. And each one of the files has a different language. And these languages are the ones that I downloaded. And these are just the files themselves of the methods of the language. So the ones outside of here, I'm not really sure. I think they're slightly different for each one. Yeah, here, then it's gonna talk about a bunch of stuff. But if you go in the folders here, then you can see that each one of these files has the name of the methods, and is the description here, I think, if you open this on a browser, of what the method does and how you should use it. So at least that's what I think right now. I'm pretty confident that this is what's actually happening. So each one of these are one main category, the folders, and inside of the folders you have the subcategories. So Redux I didn't look at personally when I was trying to build the scrapey stuff, but I looked at CPP, and here the names are very similar, are actually the same. So you have algorithm at first, so it's the category, then you have the utility here, and then each folder contains a subcategory. And I guess when the site shows the show more button is because it's displaying this one first, and then shows more here, and then here. Yeah, and this one has subfolders. So on the website it shows all in one list, but here you have separated by folders, which is nice. I also made a lot of progress the scrapey stuff, and I actually understood how it works a little bit better now. And I think I can see the light at the end of the tunnel here to build this stuff with scrapey, because I can just use these coroutines here, and it doesn't. I thought that I would have to put a lot of them if I wanted to reproduce what I did with the code gen stuff here, but I don't think that's gonna be the case. So what this does, at least so far, when I ran the thing yesterday, it produces a text CSV with one column, which is the links column, and then each element inside of this element, which is the main div there, that contains all the subcategories for the language. So you have algorithm here, and then I have atomic and all the topics. I think that there's one missing. Might be this one instead. Yeah, it's this one. This one was a variation that I was doing there that didn't work out really well. So this one contains all the categories from the algorithms to the utility for the language. And I managed to get them. Then I was trying to figure out how to transform these links so I can get just the name and not the full thing, which I think it might be possible to do. It's going to take me some time to research. And I also spent a bunch of time trying to figure out how to make the response, the view response, I think it's view response or response view, something like that, on the Scrapy shell work here, because it is not working. I believe it's because I'm using Linux, and then the Linux can find the file after it initializes. And this view response is just a tool of the Scrapy shell, so you can debug stuff live. It pretty much opens a browser like the Playwright would do, but through Scrapy, and then you can debug stuff. But I couldn't manage to make it work because there's not a lot of information out there on this problem. So my idea here is, since I'm looping through this, well, first I want to create a function. I'm going to create a function that calls this function, passing a different element every time, depending on how many languages I want to do. And then this element is going to be this link here. And then I'm going to pass the element here. The way that I can just do the same functions for a bunch of languages instead of just one. But that's just at the end. Then, from what I understand so far, this scrapy.request is gonna make a request, and then when you put this meta dict here, you're gonna run Playwright, and you're gonna include a page object from Playwright, and then you're gonna do the subcoroutines here. This one clicks on the main section of the website, which is here, I think. Then this one clicks on the list that shows up after you click on the main section. So when you go through that link, I think it's CPP, it's a different page, and is the one that I'm doing because it's just easier. But I think I could do this on the main page as well. It would just require more page coroutine stops. So I think I prefer to make it the way that I'm making now because it's easier. So instead of making it to wait for selector, because I think for some reason that wasn't working, I decided to do with the click button, and that now it seems to work. So it clicks on the main section, which is the section that contains this. Then it's gonna click on here. No. Then it's gonna click on this div here that contains all these categories. And after it does that, it's gonna run this function here, which is the sparse function. And this contains the response. This links is that div there is pretty much these elements here. And then I'm looping through them and creating a dictionary. I'm using yield and not return because yield generates one each time and saves it in memory, and return doesn't save it in memory. So because it's you're making requests, it's not necessarily because they sync, because you have to put yields regardless if you do async or not. So I think it's because you're making requests, the program probably needs to know the previous state in order to run the next state properly. So you need to, I assume that's the case here, but I'm not really sure. But you need to keep these values in memory. So that's why you use yield. So what I'm gonna try to do is invert this and put link here, and then here an empty string, because I want each one of these elements to be its own column first I want to try to figure out how to get only the name of the section and not the entire div there. Because here is showing up href showing up the entire thing, and I want to get just the data slug here, which contains the name of the category. So if I manage to figure that out, I'm gonna invert this and I'm gonna put this stuff here so it creates one column, and then right after that I'm gonna create another function below this function here that pretty much runs the same stuff but for the category itself. So I'm gonna call the request again on that function. Now I'm gonna call the request again and use that other function as a callback instead of this one. So after it finishes the new request, which is gonna be pretty much a copy of this, but with an extra step, which is gonna be to click on the section, whatever section it is. Then I'm gonna pass the other function as a callback, and the other function is gonna create a bunch of rows in the subsection of the column. It's kind of hard to explain, but imagine as if each one of these is one specific column and not so right now they're all part of the column link. What I want to do is make one each their own column and then passing the subcategories for each column, which is going to be the other yield function. And then inside of the function, I'm going to do the check to see if there is a show more div or not, and then call the function recursively until there isn't show more buttons. And then after it finishes with that whole thing, it's gonna go back to this loop here because it's gonna do that for each element inside of this div in the main request. And I think that's gonna work. I'm pretty hopeful that that's gonna work, as long as I understand how to get the selectors correctly, which was the problem I was having, and also something that I'm gonna study now. XPath and selectors. I'm not very good at them. So now I think I'm gonna put some music here. And I think what I'm gonna do is I have to remember a bunch of stuff. Oh, here's us searching for listening to her Mac. And searching for a bunch of closure, for a bunch of JavaScript stuff. This is from the video I saw. And by the way, this closure thing here, that on the video the guys was saying that it's hard, I think it's actually the same thing as a decorator in Python. At least it seems like it's pretty much the same. So based on the description, like closure is pretty much a function that can access a variable outside of the scope of itself. So it's inside of this other function, but it has access to this name here inside of this. And for me, this is pretty much the same syntax as the decorator in Python, where you have a wrapper function here that wraps this function, and this function adds functionality to the main function. So I think it's interesting to see that the same concept applies on the two languages. So I think they're very, very similar in practice. The only thing that changes is the syntax slightly. So what I need to search now is, first I'm going to import pandas as PD, because I'm probably going to use that. Then I'm going to import the OS to list the directories. So let me do some mocking code here. So loop through blank docs. Access, I need to create something that is going to recursively loop through folders. but each language has to be, yeah, so each language is going to be an element. Each folder, which language folder is going to be an element of the link docs loop. Then I'm going to create another loop, create another loop, should loop through the folders. Oh, and while I do this, I'm going to push folder name through a separate list containing language names. So my idea is create a bunch of languages outside of these loops where I put each name, but it might be better to actually make a dictionary. So I have to think about, because ideally I want to have the structure as it is on the folder here. So whenever something is inside of a folder, it goes inside of that thing. So I have to think about if that's possible, how it should do that. I think for the loop outside, this first loop is not necessary. But then for the other loops, it probably is. Language folder is going to be an element of the link docs loop. So I need to loop through the folders recursively. And it's going to be better if I separate these into functions, I think. So maybe create a loop for the main one and then put this on a list. Yeah, that's probably the best. Loop through the link docs push folder name to a separate list containing language names. I was thinking about putting them into a list and then creating a separate function that's going to take that list as an argument, or each folder as an argument, and run that function through the list. But then I have to check. Yeah, I think the OS stuff, I think it's os.list directory to access directories. I think that's gonna work if I do like this, because the link docs is gonna be always the same, so I can just access the folder through that, or just get the path. Yeah, I think I have to see if I can get the path of the folder just with the name. Oh, I can do a string actually. I can do a string and then make the f and put the name as a variable. So while I'm looping through while I'm calling the function, I'm passing in yeah, that's gonna be the best way to do this. So push folder name to a separate list containing language names. Create a separate function that is going to take each name as an argument and create a nested dictionary. of all files and folder names for that language. So 1, 2, 3. So let me change this music. Maybe I leave this one. Never heard it before, but might be good. So loop through link docs, push folder name to a separate list containing language names, create a separate function that is going to take each name as an argument, and create an asset dictionary of all files and folder names for that language. So that way it separates each folder as its own block. Each language has its own block. And then I need to pass that dictionary to create a CSV file. It should be an element of things up. So I'm gonna do that first, then I think about the rest. How to loop to a folder in Python. I think it's OS list directory, but I'm not sure. OS list directory. Oh, I was confused with you. This one here. For item in OS list directory. Now I need to get the path. Oh, I think I'm gonna research how to make the path resilient. Because you can use OS path name there. OS path, OS directory, something like that. Maybe we should search this on another tab. I need to start making things like this instead of the way that I'm doing them now. Because I think this is more resilient in case you have to change the folders later on. So I don't have to rewrite every path each time. I think I used this function somewhere. I just don't remember. Oh yeah, it was on the network X stuff. I'm gonna open here. So I think it was this file. Make sure path exists. This one. So let's see how this works. Try to make a directory path. So if it already exists, it's gonna throw an error and then it just goes through the exception. And I think this is a good way to do this. I'm gonna study a little bit to see if there are more ways, but it's just me. Yeah, and then I need to make this equal to a variable, I guess. Because otherwise it defeats the purpose. I think this is too repetitive for me. This music. Maybe if I search for how to make resilient paths in Python. This one might be good. Yeah, so I think this function gets the directory of the file where you run it. And then you put the file name. Depending upon whether it's a module or a single script, and where you're invoking it from the same directory or from a different one. Let's try this one. Uh, File name. And here is obviously gonna be the name of the file, the folder. So first it makes sure that it exists. Yeah, but then if it doesn't exist, it's gonna create one. Yeah, but I don't think it matters because oh, and I have to import this. Nice. So it works. It's interesting that it's not giving me the file though. And there's this docs.json here. Oh no, here it is. Nice. So now I'm gonna do if item not find is equal to -1 print item, because I wanna filter out the file. Nice. So now if it has a dot, it's not gonna run through it. But this one's not showing up because it says 4 points and Python 3 point down. Maybe there's a better way to do this. Each iterate through subdirectories of a given dictionary directory and search for files. If I get a file, I have to open it and change the content and replace it with my own lines. So I have the root there. For subdir, there's files in os.walk. For file in files, f equals open file. The actual walkthrough the directories work as you have coded it. If you replace the contents of the inner loop with a simple print, then you can see that each file is found. So maybe I should search for OS walk. Python walk generates the file names in a directory tree by walking the tree either top down or bottom up. Found the syntax of for walk method. Let's walk top down. True. Oh, this is interesting. Each directory rooted as directory. Your path, their names, file names. If optional argument top down is true or not specified, directories are scanned from top down. Top down is such a false, directories are scanned from bottom up. This visit this directory's pointed should be true by seeing links. So I think the default value is true. If optional argument top down is true or not specified, directories are scanned from top down. Yeah. So it's the default is top down. I can just use this.
Dit,
What we're
trademark
gonna
Highland.
search for. Maybe this is a good video to watch as well. So maybe this OS walk function does exactly what I wanted it to do. What I want you to do here. Let me do OS walk. And then I'm gonna do the same structure that the guy did there. Let's just see what I get. Which is files, subdir and dirs. Then here I'm gonna print files. Control D to reproduce the print statement. Maybe it should break on the first iteration, just so it's easier to see. So I guess docs.json. So the files docs.json, directories, and subdirectories link docs. Oh, which is the directory that I'm on right now, I guess. This is very interesting. So let me do 3 times, just see. Uh, Maybe plus plus works here. It doesn't. Yeah, so let's see. This is the second one. Interesting. So it's getting the CPP stuff now. And I think it gets, maybe I should pretty print. I'm gonna do this up here to skip the first iteration, because the first one is not that interesting. Yeah, but from what I understand here, you're going to get the C++ stuff. Yeah, utility. Huh. And then it's going into these ones. It's getting range here. Then the file names. So this is exactly what I need, actually. So files. So let me do it like this. Because I want to see if it does on different folders as well. Maybe I can do this as well here. I can make it a dictionary. And then I can do files. Uh, So the last one, they have the files. There's some there. See the first. God damn. Yeah, I guess it's because there are a bunch of subfolders. It probably goes through all of them. Oh, I'm doing the other way actually. That's why. Now it should be better. So files. Yeah, this is the main one still. So I think it probably doesn't do what I think it does. This condition is also doesn't make sense. Don't know what I was thinking there. I think it's better to watch the videos to understand better.
Welcome back, Python family, to the Python Made Easy series. This is going to be a phenomenal session. If you only have time to review one presentation or blog or site on os.walk, let this be the one. This presentation is jam-packed with explanation and example. I believe you will walk away with a very good understanding of this very powerful tool. Here we go. What is the os.walk function? os.walk is part of Python's OS built-in module. The OS module, as you might recall if you've been following along in this series, consists of operating system interfaces. It gives you a portable way of using OS-dependent functionality in your Python code, so it's independent of the OS that we're running our Python code on. os.walk allows us to generate file names in a directory tree by what they call walking the tree. So we're able to get at folders and their subfolders and the files in every level. For each directory in the tree, a tuple of 3 elements is returned. Dir paths, this is the path to the current directory. Dir names, these are the subdirectories in the current directory, or at dir path. And file names, this is a list of the names of the non-directory files in the current directory, or for dir path. Okay, so let's see what this looks like and what os.walk is all about. On the left-hand side, I have my code. On the right-hand side, I have a directory structure that we're going to be acting upon.
Oh, no, it makes sense. So instead of looping through file name, I can create the loop with the files, with the folders here. Because I think this OS walk is only gonna have access and it's gonna create this stuff only for the folder that I'm calling here to walk. So it's exactly what I wanna do, actually. It was the function that I was gonna do when I tried this. So I can just, instead of doing that, I can just use OS walk. Yeah, I get all the file names. I loop to the lang docs, get all the file names, then apply OS walk to all of them, and create this dictionary here. Then I can filter the files part of the dictionary for only HTML files. Let me keep watching the video, then I think about it.
Using os.walk. So let's start from the top. My_dir is a given directory path that you see exposed on the right-hand side. It stands for users/my_tests. So the first thing I want to do is just print out start print. So we know where we're starting and we know where we're ending. I'll print out end print at the end. So for root dir path, subdirs, and files in os.walk against this directory my_dir. So this is this tuple of 3 elements that we're setting up, right? Root dir path is the root of a given directory. Subdirs would be the subdirectories inside of those, and files would be the files inside of the given root path. Now, the first thing I want to do is I want to be able to show you what the output looks like for each of these. We print the root, we print the subdirectories, and we print the files. I'll end each segment or iteration with 25 asterisks, and then I'll print end. Okay, we'll go to the next page and we'll see exactly how this looks and how it compares to what we're seeing in our directory structure on the right-hand side of the page. Okay, and here's the output. So at every level, we have a root directory path. So that's the first element of the 3.
Yeah, let me test something. So I'm gonna copy this structure, key, file, key, folder. And then I have to filter out this folder. Green. There we go. And here's double because I don't want to assign the key to 3. I just want to verify if it's equal. So yeah, this is the idea, I think, here. We just loop through the file name enumerating it. So each key is going to be an index, and the folder is going to be the folder, obviously. I'm just putting this key equals 3 to see what happens in one instance of the thing. Then I'm going to apply the OS walk to the folder and return this stuff here. Let's see if this works. It doesn't print anything. So print key, print folder. And that's why. So I can't enumerate the file. Oh, I forgot the OS list there. Now I'm gonna comment this out to see if I got it right. Yeah, now it's correct. Also, I have to think about how do I get this file out of the way, but I'll think about that later, I guess. So I'm probably doing something wrong here. Oh, I'm getting the index of the file, which is 3, if I remember correctly. It doesn't work. What's going on here? So the key is 0, folder CPP. Oh, it's because I'm only getting the name and not getting the path. So instead of doing this, I can make the folder path equals this one. And here I can just put folder. Then I put folder path here. Let me print this folder path. Yeah, now I'm not sure if it's gonna work, but because I'm not sure if I should use current directory or, but we'll see. That doesn't work. I wonder if I close the tab there. I think it was this one. Yeah, let's write this path instead. Here. And I'm gonna print. Now I think it's gonna work. At least it should work. Yeah, the only way to find out is run it. Doesn't work. So obviously the problem is the path. Mm. The path is always confusing for me because sometimes it works, sometimes it doesn't. I never really understand that well what makes the path break or work. Maybe I should open this in a different tab just to save that one in case I need it later. I'm gonna search this for a little bit. Oh, this gave me an idea. I can just sum this one. But it feels like a cheap solution, like a hacky solution. Because then I can erase this stuff and then just make file name plus in the folder. Oh, actually, I can make it like this instead. Because this path works, so I think this is gonna work, but I wanna see if I can find a solution that uses the OS, because it's probably better. and do it like this. And there's the backslash here, and then forward slash here. Maybe if I do it like this, it's gonna, and then I have to escape it. I'm gonna try like this and see if it works. If it doesn't, then I'm gonna do the backslash instead. Yeah, now it works. I think this is the way that I've been doing these things when I encounter these problems so far. So files, there's all the files here. Should be the the Noko GUI one. I think I'm gonna print the folder and the key. Oh, actually, the other way around is better. That way I can investigate. Bar node. Yeah, so all the files here. No directories, subdirectory. So I'm gonna get one that has a bunch of files, of folders and subfolders. I think CPP is probably the best because it is the one that probably has the most files. So I think it's the one key. Let's see. It's probably this one. Or Django. So it's probably 0. Obviously, it's going like this. So file names. So it's getting all this. And directories. All the directories. Now I think is looping through this probably. Directories range, subdirectories algorithm. Maybe I should just print the subdirectories because I want to see. I think now I understand what it does. It's pretty much going through all of them and then creates this structure. Yeah, it goes through ranges. Yeah, all of them. Really. So you went through the ranges one. Then atomic, HTML, a bunch of stuff. Atomic flag. I should print the other way around as well. I think it's better to understand. Maybe this subdirectories first. Subdirectory first, then directory, then files. Great. I think this does exactly what I want. I'm trying to think if I should put them on a dictionary or some other format, because later on I want to use this to build the nodes. Oh, actually, I'm going to build a CSV, so it's probably better to make as a dictionary. But then I should think about the format that I want. So for each key, for each folder here, I want to put all this information inside of specific lists for the file, for the folder name, which is going to be a language. I also think if I should do this on a function. Yeah, I think it's going through all the Dominic Chrono. Iterator, local, memory, numeric. So I'm gonna think. I'll be right back. I'm gonna watch the video there when I come back. And then I'll keep working on this. So let me watch the video.
Hey there, how's it going, everybody?
tuple. So it's users my test first, and you see how that corresponds to our directory structure right here. And that prints out subdirectories, PyCache and testing1, which is at that level, right? That sits in that directory, and it prints out all the files. You can see them all there. Then we go to the next level, which is the PyCache folder level, and that has no subdirectories, and it has 2 files, and it prints them out. Then we go to the next level, and that's testing1, and that has one subdirectory, testing2, and 1 file. Then we go to the next file, which is testing2, right? And that sits in the base of testing1, and that has 2 subdirectories, testing3 and testing2a, and it has files, and so it goes. And so it goes until we've gone through the whole, until we've walked, right? Until we have walked the entire directory structure from the top to the bottom. And from here until the end of this class, we are going to show you just more and more useful examples, expose you to different techniques, and become more and more complex as we go. Okay, so this one is walking the directory tree and printing out only files. So you'll start to see some very common techniques being used here and common syntax. So let's go through this first. os.walk traverses a directory recursively, and for each directory, it generates a tuple containing the directory path, any immediate subfolders of that path, and a list of the name of any files in the directory, which is exactly what we saw in just the previous 2 slides when we went through this. And recursive in this context, or recursive expression, is a sequence of instructions that loops back to the beginning of itself until it detects that some condition has been satisfied, like reaching the end of the things that we need to process. Okay, so with that, we'll look at this code on the upper left-hand side. For dir subfiles, like I can call those variables anything, but it's what they represent in the positions that they're seen as it relates to os walk that matters, right? So here I'm calling them something different, dir subfiles, just to be curt. In os.walk, I'm using my same directory my_dir. The first thing I'll do is print the directory, prints out each directory sub. Now I'm using list comprehension, n for n in sub, instead of doing a for loop, okay? And then contents, I'm concatenating the sub to the file name. And then I will sort. I'll use the sort method, so contents.sort. And then I do a loop on the individual elements of that sort. So for f in contents, if os.path is file, that's how I'm acting conditionally here. I don't want the directories, I only want the file. Print, and I'll tab in, just to make it easy to see, just the files, and I print just for space between each iteration, and you see what happens here. I get only the files at each level. So I print out the parent dir, and then I get just the files in each file that it sees. Okay? Does that make sense? I hope it makes sense. If it doesn't, leave me notes. I'll try to get back to you as soon as I can with any clarification that you may need. Now, on this page, we looked at just printing out the files. In the previous slide, now we're going to do just the subfolders, and it's very much the same. In fact, the first 4 lines of the code is the same. For dir sub files in os.walk my dir, print the directory. Then we use our list comprehension again, n for n.
Yeah, it's actually better to do the other way around, actually. These ones are in a weird order. Yeah, that would be better. At least for me, it makes more sense. Because dirs is the directory that I'm looping through. Subdirs are the subdirectories of that directory. And files is the files, obviously. So I print dirs now. Actually, and the other thing that I'm thinking now is that I actually don't want the directory. I want the name of each thing. That's what I was thinking. That's why it's weird. It was a little bit weird to me. Because I have to think about the network X part. So I'm trying to think on my mind, visualize the tree and how I'm gonna connect in the end. So I know how to structure the CSV file. So later on, I do intend to make something I can find connections between the languages in the methods. But I also want to make a clear distinction between each language. So everything doesn't get lost. So I think what I will do is overall, I'm gonna make the folder the dictionary. Then inside of the folder, I'm gonna put another dictionary. There's gonna be a nested dictionary. So each folder is gonna be a language. And then, yeah, but I wonder if I can do a column with the language name and then below that column a bunch of columns that are all attached to that one column. Kind of like you can do in Excel, where you have a column and then you merge the cells together. So below that column, everything is underneath the same thing. But I think doing that with pandas and CSV is probably gonna be more of a pain in the ass. So I'm trying to think, is there a better way? Maybe we can just do each row for our language has the name of the folder. Yeah, that's what I was thinking. Then I want each category to be, well, but that's the problem. That's the difference between what's here and what I was thinking. Because in my mind, each category, because in the site, it's by category and it doesn't, these subcategories don't contain other subcategories in the website. And the way that I was thinking is each subcategory is gonna be one column. Because I wanna create the CSV in a way that I have a tree structure. So it's easy to build with the network X. I also wonder if I should put this on the function as well. Or if it's not necessary. And maybe I should put the on a function. So each folder has to create a sub column, if that makes sense. So the challenge here is how to structure that in a CSV.
In sub, which is iterating over all those different subdirectories. We'll sort on the sub, and then we do our printout for F, the individual subdirectory in sub, print, and then we'll tab over just the subs, and they print out. You see as they do. So these are just the subdirectories in that directory structure that we've been using. Okay, so not the files this time, just the subdirectories. And you see down at the bottom, the testing 3 and testing 2A don't have any subdirectories. Okay, so I'll fly in this directory structure again, and let's just verify that. Okay, 3, it has files. 2A, it has files, no subdirectories. So why aren't the files printing again? Because we're only printing subdirectories, right? So all is well. The objective of this snippet of code is to count all the elements in our directories and subdirectories. We don't care if they're directories or files in this particular case. So we're going against users test, a different directory. It's a little bit smaller to
Today's
some of these
video
examples
we
easier
are
to
going
understand and see. So you see that on the right-hand side. We set a counter, count underscore file. It's an integer, it's equal to 0 to start. Then we go into our for loop for os.walk, path, sub, and file names. In os.walk, we point it to that directory dir1. We have our list comprehension on the sub, n for n in sub. So we iterate over all the subs, content equals, and then we'll add together the subdirectories and the files. And we'll use that in our next for loop so we can iterate against all its elements and add them together and add the sub to our counter, count underscore file. We increment by 1 right here. And then when it's all done, we print it out and we see that we have 10 elements. But if you were to count all the files and folders on the right hand side, say, wait a minute, I think I see 9, you'd be right because .ds underscore store is hidden in this particular view that I have for you here. So it is 10 all as well. Now, if you're working on these examples right alongside me, you might have recognized that Python put some weird files and folders in a repository, and you may want to do without those. So for instance, we have these dunder folders, or these folders that have dunders or double underscores at the beginning and the end of their names. So in this particular exercise, I get rid of those. I don't want to see those. So if not path.ends with, in quotes, underbar, then print the path. And you see it does a very great job of quickly getting rid of those so they're no longer in my view. Now, staying with the theme of excluding some of our subdirectories, here what I did was I have a few folders in this test parent folder that start with numbers, 1 dot, 2 dot, 3 dot. You see them here up at the top, 1 dot test, 2 dot test, 3 dot test. And I decided I don't want those. I don't want anything that starts with a number and then has a dot. So what I do in this for loop for dir in dirs, if not dir1 equals 1. So I'm saying if in its second position, in zero-based indexing, that would be the second position for the file name. If it doesn't have a dot there, then give me that in my return. So that's an easy way, a very easy way, a few lines of code to be able to exclude those folders that you don't want, in my case, in its second position where I have a dot. Remember, these are just strings, so we can apply slicing and indexing, any methods and attributes that we can use against a string, we can use here. So if you're ever confused about that, you can go into Python Interactive, you could either do a dir against str, or you could create a string 1 equals foo, in quotes, and then do a dir against string 1, and it'll bring you back all those methods and all those attributes that you can use against the string. I encourage you to play.
Well, the other thing I'm not thinking about here, but I guess I can do that later, is that I only want the HTML files. Because the HTML are the ones that have the name of the stuff that I want. Any other files, I have to filter out. I think it was on JavaScript maybe that I saw. Yeah, meta.json, for example. Index.json. So I wonder if I create if HTML files. Yeah, because I'll have to loop through the files. So maybe it's just better if I do it with the other types of files. I can use filter as well. At least I think. Yeah, filter. I'm not sure if this works. Hmm. Shouldn't be too difficult to figure this out. Oh, if I cast to a list, maybe it works instead of the filter there. Outside of the filter. So why is making that? Filter. Oh, should be inside here. Ah, there we go. So this works, I think. Now I only have HTML. Yeah, this is what I'm gonna do, sure. Filter all out the other files. And if there is some HTML files that are not necessarily methods, I think that's okay because it's probably not gonna, it's gonna be the exception and not the rule. So it doesn't matter that much. If I'm doing this through Scrapey though, it might be different. Yeah, the structure is gonna be different. But then I think I can figure out as well. It's not a problem. So how can I see this if it's really working or if it's not the same? I think it works. I don't see any reason to think that this doesn't work. I'm using the function to find .html in X. And going through the files list to filter, and then turning that into a list again. It is not necessary to put the wild card there. can also use x.find and then the HTML. This works. So I don't need to do this. I can just leave it like this.
To go over
with those. See what you have at your disposal, because when you need that tool, you can just pull it out of the toolbox and use it. We're going to use a system method here to rename directories based on conditions. We're going to use os.rename. And os.rename has a source component and a destination component. So let's see what the directory structure looked like before. Before is in the upper left-hand corner, after is in the lower left-hand corner. We're going to be focused in on the files that end with .test. Okay, and we see that right here. Let's go through the code top to bottom. So for root dirs files in os.walk dir1. dir1 is the directory we're feeding it, and that's users/test. For d and dirs, we're focused in on the subdirectory level. If d.ends with .test, now you see that we have many, in fact, almost every single file and folder has the word test in it, including the parent. But we only want, in our population of things we rename, are those folders, those subdirectories that end with .test. So you know right away that will just be the first three here, 1.test, 2.test, 3.test. So then the print d, we don't need that. That was just for my purposes for testing. That doesn't help this to run at all. os.rename source is root.os.sep.d. That's what we have now. And what we have to do to make this work is we have to give it the full path. If we don't give it the full path, os.rename will not work. And os separator, the separator is the character used by an operating system to separate the path name components. So for Linux-based systems, Mac-based systems, it'll be the /, and for Windows, it'll be /. So we give it root.os.sep plus d, which is the actual name of that subdirectory. And again, it'll only pull those if it ends with .test. And then the destination will be very similar, root.os.sep plus d plus a period plus the word new. So you see that we were very successful in this because those three folders here have now become 1.test.new, 2.test.new, and 3.test.new. So mission accomplished, we're good. So we're going to do the very same thing here, but instead of using the os.rename, we're going to use the os.replace. Other than that, everything is exactly the same. I just wanted you to know that you can absolutely do this with two different functions or two different methods, both from the os module in Python. One thing here is I'm changing the destination. So instead of 1.test.new, I want it to be new in the front of the word and then the number 1 in the end. So look and see what I did here. For the destination, root.os.sep as always. Then I go right to the word new, and then I'll add d, the file name. However, I'm using a slice, and I'm using :-5. So from the start of the string, d in other words, our existing file, up to but not including the -5 index from the right side. So what that does is that'll give me the number, but it doesn't give me anything to the right of that. So it doesn't give me the period test. So I'm left with, for 1.test, I knew 1. For 2.test, I knew 2. For 3.test, I knew 3. Okay, that's back to just, again, whatever we can do to a string, we're able to do to the names of these files and directories. So it's kind of neat. In this example, we'll print out all files in all directories and subdirectories except for those files that end in .py. So no love for Python files in this example. So for path subdirs files in os.walk mydir. For file and files, if not file.end with .py, and also I'm sick of those, the hidden file that starts with a period, so and not, compound if statement, and not file that starts with period. File path equals os.path.join. So I'm going to join the path to the file using os.path.join, and then I'll print out the file, and you see what we get. We indeed do not get any files that start with period, and we get no Python files. Right here, I want to get the size of each file and the last modified date. So I'm actually going to make use of some methods from the time built-in module in Python as well here, just for a little section of this code. I'll walk you through it. So for path subdirs files in os.walk mydir, for files and files, if not file that ends with pi and doesn't start with a period and doesn't end with .pyc, another type of Python file, I'm excluding those as well. File underscore path equals os.path.join path and file. So we saw that in the previous.
Think about the points. I can move on to the next one.
for tree data structure, and by tree I mean general trees. There are binary trees and binary search trees, which we'll cover in the future tutorials. As usual, we'll go over some theory first, then we will do implementation of general tree in Python, and in the end, we'll have an exercise. And here is a list of topics, just in case if you want to skip ahead. Let's get started. Let's say you are building an e-commerce website for electronic items. Here, the item categories might look something like this, where electronics item can have laptop, cell phone, and television as a category. Cell phone might have iPhone, Google Pixel, or Vivo as subcategories. You might have seen this kind of product hierarchy on Amazon.com or eBay or any other website which sells electronic items. Now, to represent this in terms of a data structure,
I can probably run those algorithms that I don't really know the name, but that's a very common, I think. I forgot the name of them. Oh, breadth first search or something like that. There are a bunch of algorithms to organize this list.
Now we have studied linked list, array, stack, queue, etc. data structures. Pause for a moment and think if you can use any of those data structures to represent this information. You will find that you cannot use stack, queues, linked list, etc. to represent this product hierarchy because those are linear data structure. In sequence, you store list of items. Here, the information that we want to represent is in hierarchical form. It is like a tree. So just visualize that you have inverted a tree where the electronics is the root of the tree, and then let's use of a tree called ancestors. And for electronics, cell phone max 2 children, but we are going to cover binary tree in future tutorials. So for this tutorial, we are going to just focus on general tree. Now let's build this tree in Python. I have opened PyCharm here and created this class called tree node class to represent the tree. This class has data as an element, which will represent whatever data you want to represent. It could be a string, number, complex object. It will also have children. So this children will be a list. Each element in this list will be an instance of tree node class. Because remember, tree is a recursive data structure where when you have a node, the child node is another tree in itself. Hence, each of these elements will be an instance of tree node class. You also have parent property, which will store the parent of this particular node. So this tree node is an individual node within the tree. All right. Now let's add a method called add child. So here, what we're doing is we are adding a child node into our tree. And it is very simple, actually. You can just do self.children.append. Now I'm keeping my data structure simple and not checking for duplicate, etc. If you want your elements to be unique, then you can make that check. Now, if you don't know how to create class and general Python programming, I have a separate Python tutorial list, so you can go through that. At this point, I'm just assuming you know about classes in Python. Now here, we need to do one more thing, which is whenever you are adding a child, see, you are adding a child to self object, okay? And that self will become a parent of this child. Hence, child dot parent should be self. What this means is child is an instance of tree node class. It will have a parent property, and that parent property, I want to set it as a self, okay? So let me quickly demo this. Here, I'm creating a main method. And in main method, what I'm going to do is write another method called build product tree. So in this function, I will build the product tree for electronic items. So here, the first node, the root node that we have, is called electronics. So root node will be tree node, okay? And it's called electronics. So then this electronics will be stored in self.data of that particular root node. Then for electronics, laptop is one of the categories. So what I will do is I will create an object called laptop, okay, and store laptop as a string. And then for laptop, or let me just do this. Let me just add root.addChild laptop. Okay, so I created electronics as a parent, and then I'm adding root as a child for laptop. Okay, and let's run this code and let's see how it looks. So I'm going to set a breakpoint here, right click, debug, and then hit next. So this will take you to the next instruction. Okay, so you will see that here, my root has an empty children and the data is electronics. And when I add child in my root, what's going to happen? So let's see. Okay, I should have returned the root back. So let me return the root back. So return root, and that root will be stored here. And I'm just doing pass just so that I can break here. Okay, so again, debug it. And click next, next, next. Now at this point, the root will have one child, which is laptop. So here you can see the children has one element, and that element is also of class, is an instance of class tree node. And that one is laptop, and the children of laptop is of course empty right now. Now what I'm going to do is, just to save some time, I'm going to copy paste some code, and all I'm doing here is, see, I created laptop first, and in the laptop I added Mac, Surface, and ThinkPad as a child, and each of the child is an instance of tree node. That's why I'm just creating a tree node object here and appending that as a child. Similarly, I'm creating cell phone tree node object here, then adding iPhone, Google Pixel, and Vivo as child of cell phone, meaning these are the subcategories in cell phone category. Similarly, Samsung and LG are the TVs, which are subcategories of TV category. Once these three tree nodes are done, we will add it to a root category. So the electronics category will have laptop, cell phone, and TV as a subcategory. Okay, so this will complete our tree, and let's debug it to see how this looks. So again, I'm setting a breakpoint here, doing right click, debug, just to see how my tree looks like. All right, so I'm at this point here, and my root should have all the children. So if I look at root here, it has 3 children. You can see that tree node objects, and the first one is laptop. Laptop has further children, and those children are, you see Mac here, then Surface, etc. And for laptop, the parent is electronics. Okay, so if you analyze this variable in your debug panel, you will realize that your tree is properly set now. Now that my tree is built, I want to print it in a nice hierarchical format, and for that I'm going to add a print tree function in my tree node class. Okay, so print tree function is here, and in this function, what we're doing is we are going through all the children one by one, and we are printing data element in those children.
The idea of making a class makes a lot of sense. I didn't think about that, but actually this is the perfect opportunity to implement a class, because then I can make the class outside, and then I can create a separate function and property for each thing that I'm trying to do. And that way I don't need to create a more complex structure. So instead of doing like this, where I put each thing on a dictionary, I can access the class and then make properties and stuff like that. So I just have to think now. I think it's better to serialize the data as well. after I do that, just so I don't lose it. But I think it's probably possible. Yeah, it's definitely possible to run the two scripts without serializing the data. If I create the class, then I can probably do the network X in the same class as well, or in a separate class that uses the other class. They can inherit from the other class. So I can create a class that inherits from, maybe that's the best solution actually. If I make a parent class called tree, language tree, then I implement this, then I put this on a function and I implement this, then to create the instance of the class tree. Then the class tree contains the tree information, and then I pass that class tree to the network X class that uses that tree to create the graph. Or maybe I can make just a function inside of the class that builds the graph right away instead of serializing the data. Which is probably going to be a lot better, actually. Because that way I don't need to put stuff on a CSV and figure out the stuff. I can just go to the graph directly. Yeah, so I think that's very good. That's one of the things I have the most trouble with right now, and I think this is a example of that, where I'm just doing stuff because I'm used to do things like that, and I haven't used classes a lot on projects, so I'm not never really sure when to use them. But I think this perfectly illustrates the need and when it makes sense to create something like that, because it just makes everything easier. Yes, I can do the things the other way, but then it's just a lot more steps that I would take. So that's very interesting.
Now, since tree is a recursive data structure, if you know about recursion, it's like you have a child node, and on child node you can again call the same print tree function, and it will do the same thing. So let's go over it real quick. So here, first thing I want to do is I want to print data part first. Okay, so I first print data, which is, let's say if I'm calling print tree on this particular tree node, then it will print electronics. Now the second step is I want to go through all the children and print those children. Okay, so I can say for child in self.children. Okay, what do you want to do? Okay, so one thing you can do is you can say, okay, child.data, print child.data, all right? And let's see how this function behaves now. So here I can say root.print tree. So on root, I am calling print tree function, and my root is electronics. Electronics has 3: child, laptop, cell phone, and Samsung, and I'm printing them here. So when you right click and run it, see, it printed them. So electronics, laptop, cell phone, and TV. So it printed them, okay, but there are a couple of issues. First of all, I don't see a nice hierarchy. They are at the same level. Okay, so by looking at the output, I really don't know that electronics is a parent of other 3 subcategories. Another issue is I don't see the children of laptop, cell phone, and TV being printed. So how do you print them? So just think about it. So again, think about recursion. Here, instead of doing print child.data, what if I do this? Since child is also an object of tree node class, and tree node class has a print tree method, can I do this child.print tree?
Yeah, but now it just occurred to me that it's probably better to create a different class for the network X part, because in case I want to create specific trees but not necessarily build a graph from them. So there's 2 ways to go about this. I can either make an attribute to the tree class and store information about each specific language there. But then I think that's gonna be a lot harder because I'm gonna have to redesign all the other methods because I'm using the OS walk to get the information about the files. So if I start just everything in one thing, it's gonna get really confusing. I think it's more clear and better to separate each language into a tree class. That way I can just use the OS walk and store the information for one specific language in one instance of that class. And then I can use multiple instances of that class to create the network X class. That makes sense. So I can use a class, should build one tree for each. Yeah, one tree for each language. Then use that the attributes of the class in the other class to build the network X. I think that's the best way.
So I'm doing child dot print tree. Just think about it. It will recursively call this function and print the subtrees. Now, one issue that will happen is when you are at leaf node, it will not have self.children. Self.children will be an empty array.
So I think I'm gonna type it here, just the first part. So I decide the names. Blank tree. And this is not gonna take any argument, I guess. Def init soft. So now I think I'm gonna make theirs up there. Pause. Can initialize each one of them to an empty array. Maybe it's not best to do like this. So I'm getting some warnings here. This link line. Class names should use camel case convention. So length tree. Alright, this value is not used. So maybe I should put this equal theirs instead. Oh, I was talking about this one. Yeah, but I guess like this is better visually. Shadows named theirs from outer scope. I was talking about these ones. Let's see if this goes away. Yeah. If files. Just so it's not equal to the names here. Okay, now all the warnings went away. Now I have to think about the design of this class here. I wanna call this class each time I'm running this OS walk here. That's my idea. And then I'm gonna have another class, and then I'm not sure if it's gonna inherit from link graph. I think I can inherit from link tree, but I'm not sure if that's the best way. Yeah, I'm not sure if I'm doing this just to use the inheritance because I never used before, or because it's actually a better design. The way that I'm thinking right now is that it makes sense because each link graph, well, but a link graph, yeah, it can be an instance. I don't think it makes sense actually. I'm gonna research this, but I think it's better to do it like this. Because although they are connected, the link graph is not necessarily using one link tree. You can use multiple of them. Because each link tree is going to be one language, so I'm going to put languages here just for now, so I put something here, but self.languages. It's the warning here. Too many blank lines. Yeah, so I think I'm going to leave it like that for now. Then I'll think about it. I'm also thinking about putting this in a function. This loop here. I think it's better design than to leave it like this.
So you can put an if check, say that if len of self.children is greater than 0. Now this condition is
Let me see
same
how
as
much time
saying this.
spent here.
When you do if this, it will check
Almost
for
2
the
hours.
condition. Okay. All right. So this looks good now. Let's try to run this and see what happens. All right, great. See, I'm seeing now all subcategories, the entire tree being printed. The issue that still exists is I don't see the nice indentation which can tell me who is parent and who is child. To print the indentation, we need to do a couple of things. Okay, so let's think about it. So here, when I am printing my self.data, based on which level I'm at in the tree, I need to append some spaces in front of me. I want to print a tree which looks something like this, where there is electronics, the laptop is one category, then Mac, and so on. So this is my ultimate goal. And what I'm getting right now, if I print this again, is just a flat list. Okay, so how do I get this kind of nice hierarchical tree being printed? Based on a level, I need to append some prefixes here. So here, let me go over what is level. So if my node is at level 0, then I don't want to have any prefix. But if my node is at level 1, which is laptop, cell phone, and television, you will notice that for laptop, cell phone, television, there are, like here, maybe 2 spaces, here 2 spaces. And if you are at level 2, maybe here, there are 4 spaces, So I want to append all those spaces in front of my node. So first thing we need to do, of course, is we need to create
Actually, I'm going to
get
use this design that he's using. Seems to be better to create the tree. So instead of doing this, I can do data. I'm gonna use the names he's using there. Children. Parents. Yeah, because he's teaching the structure of the tree. So I'm gonna follow that structure and then figure out how to make it work for this case specifically.
level function, which will get me the level of my node. So I will call it get level here. And what this get level function is doing is it is just telling you if, let's say, you are a ThinkPad node, it will tell you that your level is 2. So just see, ThinkPad here is at level 2, laptop is at level 1. So it will just tell you that. Now, how can you tell you that? So one idea is you can count number of parents. So for ThinkPad, laptop, and electronics, these are the ancestors or parents that you have. So if you can just simply count number of your ancestors, then that will get you a level. So for ThinkPad, laptop, and electronic 2, so that's your level 2. For laptop, there is only one ancestor, which is electronics, hence the level 1. And for electronics, there is no parent, hence the level 0. So all I need to do is count my ancestors. And how do I count that? Well, you have parent property here. So we can do this. We can initialize the label variable to 0, and we can say, okay, my p is self.parent, and while p is equal to p.parent. So you keep on going through your parents, and you increase your level. And this will be your level. So return that level. So in this while loop, what we did is we assign p to p.parent. So just going by this example, first we say for MacBook, my p is p.parent. So your p will come here, then p comes here. Then this guy doesn't have any parents, so it will stop. And in that loop, we can increase this level counter. All right, so let's try this out. So I'm going to probably instead of printing the tree, I can print root level. So root dot get level. Okay, let's print that and see what happens. So root level is 0. That's what you expected. Okay, so that part works fine. How about I print the level of my, let's say, TV. Okay, so here I can say print TV dot get level, and when I run it, I get 1. So looks like this level is working. Okay, all right. So now how do we use level function to do a pretty printing of our tree? In print function, all we need is in front of self.data, we need to print some prefix. Okay, and that prefix will be number of spaces based on the level. So well, based on the level, meaning I can get this self.level. Okay, and for each level, let's say I
also need to research about super because I forgot a little bit about super and class inheritance. And choose either one. I think super allows you to inherit the attributes of parent class. And when you're inheriting the class, it's probably a difference.
give 2 spaces, for example. Now, how do I give 2 spaces? So if you do this, spaces. Okay, so if you do this, what's going to happen is if your level is 2, it will initialize two spaces. Like, but I mean, I'm not using exactly 2 spaces. For each space, I'm doing 3. Okay, let me remove it just to avoid any confusion. Okay, so if my level is 2, 2 spaces. Level is 1, 1 space. Pretty simple. Okay, let's just print the spaces first. So I'm doing printing spaces, and I forgot to uncomment this code, of course. So see, nice. So now at least I'm seeing 1 space based on my category. So now this looks like a hierarchical tree. Just to make visualization more better, maybe we can add more space. Okay, so here for each level I was adding 1 space, but what if for each level I add 3 space? So when you run this 3, see, you have more spacing. Okay, if you add, let's say, more space here, it's gonna just increase the indentation, you see? So that's the goal here. Now we don't want just spaces, we want it to look a little better, so we can just create this prefix variable, and we can say that will be spaces plus, use some character to represent the hierarchy. And that will do if self.parent, because for the root node, I don't want to do anything. Okay, so if the node is root node, then this is a ternary operator in Python. So I'm having my prefix here. Okay, and when I run the code, my tree is printed so nicely. Excellent, good job. All right, that's what I had for this video. As usual, I have an interesting exercise for you. I'm going to provide a link of this exercise in the video description, so don't forget to check it out. Here I have given the hierarchy of companies management, and you want to build a tree using the same class that we use in this tutorial, and I'm going to provide that class link in the video description as well. So you can just extend the class and build this tree. Now this tree is a little different because this tree has the name of the person and the designation. Okay, so Nilipul here is CEO, Chinmay CTO, and so on. Now, your goal as part of this exercise would be to write this kind of code, which can take what do you want to print, like what kind of tree you want to print. If you say I want to print only names, then it should print this middle tree. If you say I want to print only designation, it should print this, where it's just a organization chart for designation. If you say both, it will print name as well as designation. Okay. Now I have a solution link here, but I expect that you work on this on your own first. If you directly look at solution, then I'm gonna inject coronavirus in your computer, and your computer will get a high fever. So if you want to prevent that, please work on it on your own first before clicking on this sacred link. So you.
Yeah, so that's the only thing that I did there. Self.children is an empty list. Data is equal to data. But when does he use data here? Print self.data.
Keep on going through your parents and you increase your level, and this will be your level. So return that level. So in this while loop, what we did is we assign p to p.parent. So just going by this example, first we say for MacBook, my p is p.parent. So your p will come here, then p comes here, then this guy doesn't have any parent, so it will stop. And in that loop, we can increase this level counter. All right, so let's try this out. So
I think it's on this last method here. I build product tree that he uses. Oh, that's a function outside of the class. So he's making 3 nodes, making an instance of the class. Oh, so he did in a different way that I'm thinking about. Yeah, that's a very different way. Because it's adding the child manually, and I want to do it from the lists there that I have. So essentially I want to do this, but inside of the class and in an automated way. So I think I'm gonna copy the methods he did here on the class tree node.
Print function, and it will do the same.
Then I'm gonna see. I want to think about what I wanna achieve and change the code.
thing. So let's go over it real quick. So here, first thing I want to do is I want to print data part first. Okay. So I first print data, which is child.data. All right. And electronics, laptop, cell phone, and TV. So it printed them okay, but there are a couple of issues. First of all, I don't see a nice hierarchy. They are at the same level. Okay. So by looking at the output, I really don't know that electronics is a parent of other three subcategories. Another issue is I don't see the children of laptop, cell phone, and TV being printed. So how do you print them? So just think about it. So again, think about recursion. Here, instead of doing print child.data, what if I do this? Since child is also an object of tree node class, and tree node class has a print tree method, can I do this child.print tree? So I'm doing child.print tree. Just think about it. It will recursively call this function and print the subtrees. Now, one issue that will happen is when you are at leaf node, it will not have self.children. Self.children will be an empty array. So you can put an if check, say that if len of self.children is greater than 0. Now, this condition is same as saying this. When you do if this, it will check for.
So I have a pen here, then print tree. I actually think I can use the string method here instead of print tree. Print soft. Oh, I have to change this. So the string method is the thing you call when you wanna see the class. I'm not sure if I should use string or wrap. Wrap R, I think. But I think they both do the same thing. It's just slightly different, so I have to check the difference between them. Self.children, child.print, child or print tree. String. So maybe that's why it's doing that way.
That condition. Okay. All right. So this looks good now. Let's try to run this and see what happens. All right, great. See, I'm seeing now all sub electronics. The laptop is one category, then Mac, and so on. Spaces here, 2 spaces. And if you are at level 2, maybe here, so that's your level 2. And in that loop, you can increase this level counter. All right, so let's try this out. Okay? And for each level, let's say I give 2 spaces for.
Oh, I didn't do the get level there as well. There's gonna be some people doing stuff here in my house over this. I think either tomorrow or the next day, over a week or 2. So there might be a lot of noise, and I might have to do these streams other time.
For example, now how do I give 2 spaces? So if you do this, spaces. Okay, so if you do this, what's going to happen is if your level is 2, it will initialize two spaces. Like, but I mean, I'm not using
Spaces equals this self.get level times string.
2 space for each space. I'm doing 3. Okay, let me remove it just to avoid confusion. Okay, so if my level is 2, 2 spaces, level is 1, 1 space. Pretty simple. Okay, let's just print these spaces first. So I'm doing printing spaces, and I forgot to uncomment this code, of course. So see, nice. So now at least I'm seeing one space based on my category. So now this looks like a hierarchical tree. Just to make visualization more better, maybe we can add more space. Okay, so here for each level I was adding 1 space, but what if for each level I add 3 space? So when you run this 3, see, you have more spacing. Okay, if you add, let's say, more space here, it's gonna just increase the indentation, you see? So that's the goal here. Now, we don't want just spaces, we want it to look a little better. So we can just create this prefix variable, and we can say that will be spaces plus, use some character to represent the hierarchy. And that will do if self.parent, because for the root node, I don't want to do anything. Okay, so if the node is root node, then this is a ternary operator in Python. So I'm having my prefix here.
Yeah, so I know that mine is gonna be different, but because of this part right here. But I just wanna copy what he's doing now, so I can think about the things that I'm probably gonna change other things in the class as well. Because I wanna achieve a different thing. Which is good because then it's gonna allow me to practice building classes and working with classes.
Okay, and when I run the code, my tree is printed so nicely. Excellent, good job. All right, that's all I had for this video. As usual, I have an interesting exercise for you. I'm going to provide a link of this exercise in the video description, so don't forget to check it out. Here I have given the hierarchy of companies management, and you want to build a tree using the same class that we use in this.
In case I need it later. The thing is that I have so many tabs open. Difference between string and wrapper in Python. Yeah, these videos I'm gonna watch. So I think I'm gonna go for a run now. Let's see what time it is. Yeah. And I'm gonna watch these videos when I come back. Yeah, it's these videos. And then after that, I'm probably gonna stream more today. And I'm gonna try to finish this class this year. Hopefully I can finish everything that I need to do in order to build the graph today. That way I can move on to focusing. Once I have the exact thing that I want there, with the methods and stuff, I can focus on building Scrapey. And then after that, building the Scrapey version. And after that, I'm planning on changing the actual way that the network works. I want to see if I'm able to explore the data, explore the library, and figure out how to implement my new methods there. Like doing different things on nodes when you click on them and stuff like that. I think that's going to be very useful for a lot of things. So although it's going to be extremely hard because I already spent a bunch of time trying to understand how it works, but I think it's something that is worth to do. So yeah. So I'm done for now. I'll probably come back later on today. See you.